39 grams. That's the sugar in one standard can of soda, about 10 teaspoons, and your pancreas has roughly 20 minutes to deal with every last gram of it. By the time you finish this, you'll know exactly what that organ does each time you crack open a can, what changes after a year of doing it daily, and why real trouble can be well underway while your blood sugar test still comes back perfectly normal. That last part is the strange one. There is one number inside you that shifts years before glucose ever does, and almost nobody measures it. Hold on to that. I'll tell you what it is at the very end. First, meet the organ. Your pancreas is soft, pale, and roughly 6 inches long, shaped a bit like a flattened fish, tucked sideways behind your stomach. It quietly runs two completely different businesses. About 95% of it makes digestive enzymes that break down your food. The other few percent are scattered clusters called islets, roughly 1 million tiny islands sprinkled through the tissue. Inside those islands sit beta cells. Beta cells make insulin, and insulin is the whole story today. So here's the play-by-play of one can. Soda is liquid, so there's nothing to chew and almost nothing to break down. The sugar sweeps through your stomach and into your small intestine fast. Within about 15 minutes, glucose starts climbing in your blood. Your beta cells sense that climb almost instantly and dump out insulin they already had packaged and waiting. Insulin travels to your muscle and fat cells and essentially tells them to open the door and pull glucose out of the bloodstream. Within an hour or two, levels settle back down. Job done. Your pancreas handled it beautifully. So far, this sounds fine, and honestly, once in a while, it is. Your body is built to handle spikes. The problem was never the single can. The problem is the everyday. Compare it to fruit for a second. An apple carries about 19 grams of sugar, roughly half a can's worth, but that sugar is locked inside fiber, water, and plant cell walls. Your gut has to dismantle it, so what reaches your blood is a slow trickle over a long stretch of time. Soda is the same sugar with the brakes cut. Same fuel, wildly different delivery speed, and your pancreas absolutely notices the difference. But that's not even the strangest part. Table sugar and high fructose corn syrup are both roughly half glucose and half fructose. Glucose can be burned by nearly every cell you own. Fructose can't. It gets routed almost entirely to your liver. In small, slow amounts, your liver handles it easily. In fast, frequent floods, it converts a share of that fructose into fat through a process researchers call de novo lipogenesis, which literally means making new fat. Some of that fat ships out into your blood, some of it stays right there in the liver. Studies have consistently found that people drinking sugary beverages daily tend to accumulate more fat inside the liver than people who don't. Here's where it flips, and where your pancreas stops being the hero and starts becoming the casualty. When fat builds up inside liver and muscle cells, those cells start responding to insulin more sluggishly. Same knock on the door, quieter answer. Your pancreas does not give up when that happens. It shouts louder. Your beta cells scale up production and start releasing 2, 3, sometimes 4 times as much insulin to force that same glucose out of your bloodstream. And here's the unsettling result. It works. Your blood sugar stays normal. Your annual panel comes back clean. Everyone relaxes.
Meanwhile, your beta cells have been working a double shift every single day for years. That's the answer to the question I planted at the start. The number that changes first isn't glucose, it's insulin. Researchers call that early stretch the compensation phase, and it can run quietly for a very long time while every standard test says you're fine, because standard tests measure the sugar, not the effort your pancreas is spending to control it. And there's one more layer. Fat doesn't only collect in the liver. Imaging studies have found fat infiltrating the pancreas itself, wedged between and inside those islet clusters. Scientists are still genuinely debating how much that fat directly damages beta cells versus simply signaling that fat is accumulating everywhere, so treat that piece as an active question rather than settled fact. What is well established is that eventually, in some people, compensation slips. The shouting gets quieter. Beta cell function measurably declines, and blood sugar finally starts drifting up, which is often the first moment anyone notices anything at all. Now, here's the part I find genuinely remarkable. For a long time, that decline was assumed to be permanent, dead cells and nothing to do about it. More recent research suggests something different. Some beta cells appear to de-differentiate, meaning they seem to forget their job rather than die outright. And in clinical studies where people substantially reduced sugar intake and lost significant fat from the liver and pancreas, a portion of participants saw insulin response measurably return, sometimes within weeks to months. Not everyone, not guaranteed. Results vary enormously by individual and by how long the pattern has run. But the organ that looked exhausted may in many cases have been partly dormant. So that's your pancreas on a daily soda. Not a dramatic failure. A slow, silent escalation of effort that stays completely invisible on the one test most of us actually get, until it isn't invisible anymore. If you want to keep decoding how your body works one system at a time, subscribing is the easiest way to do it, and it genuinely helps this channel keep making these. Next up is what happens to your liver when you eat fructose, where I break down exactly where that new fat goes and why the liver is the first organ to feel it. Come back for that one because it's the missing half of the story you just heard. One last thing, and it matters. Everything here is educational content about human physiology, not medical advice. I'm not diagnosing anyone, and I can't tell you what's right for your body. Before you change your diet, your medications, or anything about your health, please talk to a doctor or another qualified professional who actually knows your situation.